But how could we be sure these actually were rewarding areas? How could we tell that the animal really liked the electric stimulation? In order to measure how much the animal liked it, we turn to the Skinner bar. This is a device which trains the animal to turn on the stimulus for himself. Here you notice the animal wandering toward the pedal. When he first touches it, he gets no stimulation. It's not connected yet. Then one time he touches the pedal, it does turn on the stimulation. You can see the lights go on. From here on, we have captured his interest. We count the rate of pedal pressing in order to see how much he likes it. There are undoubtedly many questions in your mind. You probably wonder whether the rat really likes it, or whether somehow the electricity just forces him to do again what he's just done. Will the rat solve a long and complicated maze problem, the only aim being to find the pedal and stimulate his brain? Let's see if he will. In this maze, you see a rat wandering aimlessly. Doesn't know where he's going. Eventually, he finds a lever and stimulates his brain. He can only stimulate his brain 3 times at one end. Then the mechanism turns itself off. The rat must retrace his steps in order to find the pedal at the other end and stim himself again. Wandering, he eventually gets there. Then he has to turn around, trace his way to the other end in order to get 3 more. One time, another time. Each time he goes faster. Gradually, he's eliminating errors. Gradually, he's learning to solve this problem for the electric stimulation alone. The route becomes more and more direct until finally he goes very rapidly back and forth. This demonstrates that he will solve a problem, the only aim being to find a pedal and stimulate his brain. Even if we take this animal out and use another animal who learned this problem a week ago, when we put him in the same maze, he'll dash around in perfect and errorless fashion to find the stimulus. All right, this is not just automatic pursuit behavior. This is also the kind of stimulation that can guide learning. I might say it's also the kind of reward that'll make an animal take an awful lot of punishment. We wanted to find just how much punishment we could make a rat take in order to find a pedal and stimulate his brain. For that purpose, we turned to the obstruction box over here. Here you see the rat happily romping across the grid. That's because there's no shock there yet. Now, I will electrify the grid. the animal must cross an area that gives a very painful shock to the feet in order to get to the pedal and stimulate the brain. No hungry rat in our laboratory has ever been willing to take a shock as large as this in order to get to food. They will die of starvation first. This shows a rat is willing to pay a very high price in order to get to the pedal. Now, what does all this show? I think we might say it shows that stimulation of this part of the brain does produce very strong positive motivation or reward. That is, it produces behavior directed toward the stimulation. It also shows, perhaps, that the human brain is designed not only for escape from punishment, but also for a considerable amount of enjoyment.
These are sensitization and to determine the relationship between our brain and our behavior.
I had no idea there were ways of reaching into the brain to touch the mind, so to speak. I'm impressed.
Well, Eric, when Mark Twain first saw a dinosaur skeleton, he was impressed too. But when he came to take a closer look at it, he found that there were only 3 real dinosaur bones, and the rest was made up out of a dozen barrels of plaster. In my opinion, the 3 real dinosaur bones represent our present limited level of understanding of brain mechanisms. In comparison with the total complexities of the whole brain, we are still immeasurably and almost totally ignorant. But there are lots of people in laboratories around the world working together to unravel these mysteries.
Thank you, Dr. Livingston. Today, more than ever before, man needs to cope with the problems involved in sheer survival. And maybe survival does depend on man's ability to understand himself. As a scientist named Paul MacLean reported, it's too bad the secret of the brain wasn't cracked before the atom.